Hi, I'm Maxwell Harris, and I'm going to describe Le Chatelier's principle and the shift of chemical equilibrium. There are multiple factors that can contribute to the shift of equilibrium. The first one is concentration. If we increase the concentration, the equilibrium will shift away, and if we decrease the concentration, the equilibrium will shift towards. So, for example, if we increase the amount of Cl4 in the solution, the equilibrium will shift to the right. And according to this principle, also, if you decrease the amount of CuCl4, then the equilibrium will also shift to the right. Another factor that can shift the equilibrium is pressure. So if you increase the pressure, then the equilibrium will move towards the side with less moles of the gas. And if you decrease the pressure, it'll move to the side with more moles of the gas. So it's also important to recognize that pressure has an inverse relationship to volume. So for example, if the volume of the system is reduced, then the equilibrium will shift to the right because the side has less moles and pressure and volume have an inverse relationship. The third factor of Le Chatelier's principle is temperature. If you increase the temperature, then the equilibrium is going to move away from the side with energy, and if you decrease the temperature, it's going to move towards the energy. So, in this example, if the temperature is increased, the equilibrium will shift to the left. And it is also important to remember that if you add a catalyst to the reaction, the equilibrium position will not shift. A good way I like to visualize this is as the flow of water. And from what I've taught you, we know that if you increase the concentration, that the equilibrium will shift away from that side. In my head, I imagine the increase in concentration as an increase in altitude, which will cause the water or equilibrium position to shift away. This can also be representative of pressure if we imagine the left side having less moles of gas than the right, and we increase the pressure as it moves the equilibrium to the side with less moles. And finally, it can be representative of temperature if it's an exothermic reaction with energy on the right side, and we increase the temperature as it will shift the equilibrium position away from the energy.